because we have a great relationship between ISSS and ENCODE. It's very important. Our responsibilities as engineers is to address these societal needs. We don't just make products and stuff. We provide solutions to all of these challenges. And engineers, as you well know, can't spell. They can't communicate. They're really boring. But we always try to do what is right. Well, we try. And context is really important. So we have the pizza example here. But you can also look at the world that we live in, and you can look at it from two different perspectives. You can look at it from the perspective of the problem, but you can also look at it from the perspective of the opportunity. And in order to really secure our future, what we need to do is we need to accept but let go of the past. Yeah? So I've got a short video that I'd like to show you, and it explains a little bit about what engineering is and what we do.
Are you sitting comfortably? I said, are you sitting comfortably? Yes. Good. Then I shall begin. The sun did not shine. The sun did not shine. It was too wet to play. There were options to choose on that cold, cold, wet day. I sat there with Liza, we sat there, we two, and she said to me, oh, what should I do? To choose a career, there are so many choices, and so much advice, and so many voices. Then the voice cried out, hey, let me show you the way. We looked and we saw him stepping on the mat. We looked and we saw the engineer in the hat. And he said to us, I can help you with that. Consider engineering, he said with a grin. Just give me 10 minutes and let me come in. And Liza and I did not know what to say. Engineering, we gasped. We would much rather play. Engineering, you see, is so very boring. Engineering, we fear, will just leave us snoring. And he said, oh, no, no, that's just not the case. Let me tell you, he said, with a smile on his face. Babbage and Lovelace, Da Vinci, Brunel, Davy and Daimler and Tesla as well. Faraday, Baird, Eiffel, Marconi and Bohr, Archimedes, Bacon, De Ferranti, of course, Kelvin, Clark, Fitzroy and Bernoulli, and the next generation could be you, yes, truly. All of these people were great pioneers. Their deeds were stupendous. They're all engineers. Smartphones and tablets, helicopters and cars, trains, planes, and even a spaceship to Mars. Boats and TVs, cameras and bridges, computer games, satellites, and even your fridges. We call all of these things systems, you see, conceived and developed by engineers, just like me. There are so many areas, there are so many branches. Just look at this list and imagine the chances. Electrical, software, civil, electronics, mechanical, business, systems, harmonics, computers, energy, aerospace, marine, robotics, materials, nano and extreme, environmental, music, people and sports, chemical, biomedical. There's really all sorts. Look at me, look at me, look at me now. Engineering is fun, but you have to know how. Be creative, solve problems, use your free will, and add to this knowledge, wisdom, and skill. If you make the right choices, then all will be clear. Let me show you just how to think engineer. Imagine the system and the people involved. There's lots to be done before the problem is solved. Say what the need is, say what is what. All the things it should do and the things it should not. Check with the people. Is this what they meant? Think how it fits with the environment. Above all else, make everything clear, and that's the first step when you think engineer. We now know the need, yes, that is so true, but that is not all we must do. The next step, you see, can be quite demanding. Analyse, think, increase understanding. Think of the problem and all it entails, when the system works well and then when it fails. When things go wrong, oh, what shall we do? Make it safe and secure for me and for you. We now know the problem, oh yes, that is true, but that is not all we must do. Take the problem we have and explore some solutions, solve and compare and make resolutions. Choose the one that works best, that we all think is fine. Do some models and maths, create the design. Look at the connections, how will it work best? Plan how to build, assemble and test. The next step I know will leave you so thrilled. We take the design and then test and build. Take the parts and components and build them up tight and look at the system. Did we build it all right? Now revisit the need and use all of your wisdom and ask yourself, did we build the right system? We built it so true, we've made it appear. See what we achieve when we think engineer. We built up the system, but that's not the end. We still stay involved. Let me tell you, my friend, we take our new system, we put it in place, we check that it works and it fits in its space. Can the right people use it? Do they think it's great? Can the owners maintain it, run and operate? We check on the system so it works just fine and look for improvements to consider next time. Now, the system works well and runs happily, but that's not the end of our work, don't you see? We retire the system at the end of the day. We recycle, reuse. Just don't throw it away. Can we learn from the system so we can refrain from making mistakes again and again? We learn all we can before we leave here. We think of the future when we think engineer. With engineering, you see, we can change the world. There are chances out there for each boy and each girl. So make the right choices and shoot for the stars. As an engineer, you see, you can travel so far. So choose the right options and plan your career. Your dreams can come true when you think engineer. With a tip of his hat and a wink of his eye, the engineer in the hat, he bade us goodbye. And Liza and I knew just what to do. So, what will you choose when your teacher asks you? Thank you.
So when I first saw that presentation, it brought me to tears. It's wonderful. So that actually reflects all of the technical processes in ISO 15288, which is the system lifecycle processes. But what a joy to present it like that. So without further ado, I'd like to introduce our first speaker, Anand. And he's going to reflect on the journey that Tata have taken in embracing sustainability.
Good morning. Am I audible? I've been working with the Tata Group for more than a decade. I'm in this industry for close to 25 years. And what I have is, what I reflect here is, what I learned from my mentors. Professor Keshav Noori, who has spent more than 50 years with the Tata Group, and Dr. F.C. Kohli, who has spent more than 70 years with the Tata Group. So most of my reflections will be biased because I've been impacted severely by the Tata philosophies. So my apologies if it is not appropriate. So first, this is a disclaimer. Whatever I express is my personal opinions, and it not necessarily reflects the Tata Group. First of all, this is not about a group. This is about a country. When JRD Tata started the great Tata Group in 1868, we were still under the British rule. And he was the only person who asked the question, okay, everybody is fighting for independence. What will we do after we get the independence? What are we supposed to do? How do we bring the society forward? So that's where the journey behind. He said that is the basis. The entire society, the entire country is the basis for whatever we are doing. And from then on, for the last close to 150 years, the Tata Group have been influencing this country, India, in a very substantial way. So what I present here is a list of torchbearers, the people who shape whatever we are doing currently. And nobody has violated the earlier principles that have been laid by the founder. Everybody has tried to refine the principle, make it better, so that the society as a whole can sustain, can thrive. So what we have right now, we have a close to 150-year history. We are present in more than 100 countries, 6 continents, and Tatas are not known for doing business. They're known for being very honest. They're known for their integrity. We We have more than 100 companies in different industrial sectors, and the revenues are more than $100 billion. There are 600,000 people who live the Tata way, spread over the entire world. And what is more important in all this is more than 2/3 of the share of the groups is held by philanthropic trust. So everything is dictated by the trust. So the trust say this is a cause for which we need to work for, and that's what they do. So the first step, it was a founding principle of JRD Tata. It said, for a business to survive, to have a larger purpose, the profits must go in hand with the commitment to society. So whatever we take from the society should be given back to the society. Society is a stakeholder. Society is the most important thing. So in a free enterprise, the community is not just another stakeholder. It's the very purpose of the existence of the business. Nothing else. This has been the underlying philosophy of the Tata Group for the entire duration of its existence. So we have a very simple philosophy here. It says, what comes from the people should go back to the people many times over. This is very true. If you are going to set up a steel plant, we don't stop by giving them only the remuneration or rehabilitation charges for whatever has been they have lost. We ensure that the entire city is set up, the infrastructure is set up, and all the facilities like schools, hospital, everything is set up and handled and managed by the Tata Group. So that we believe, the founder believe, that the cycle is being complete. So the basic premise is return to the society whatever we can, whatever we should do. And if you look at the Tata Group, it says, by definition, it is capitalist in nature, but it's predominantly socialistic in the way it acts. If there is any disaster that is happening in India, any part of the world, Tata Group people, resources, everything is pumped in there. So recently, in November 2015, there was a massive flood in southern India. So all the Tata Group organizations, whatever things that they had, whatever things that they are manufacturing, they pushed everything to that part of the country. So the other thing is, whatever has been accrued in terms of revenues, what they do is the trust get only the dividends back. They take only the dividends and use it for a variety of causes, institutions and individuals in a wide variety of areas. So that is the basis or the principle behind which the Tata Group works. So predominantly about the greater good of the world that we live in. So whatever is good for the world, that's what the Tata Group tries to support. So what is our vision? It's about impacting 25% of the world. It's saying what is the quality of life? How can we improve their quality of life by means of this Tata commitment? And the Tata says, I would like to do this. This is the quality they'd like to give for you. They ensure that they do it. So it's predominantly about improving the quality of life of the communities that we serve globally. It's not only about India. Now that we have become a global largest conglomerate in the world, we say, how do we serve globally? Through value creation, but predominantly about the leadership with trust. There is a trust in the Tata Group. The name Tata means trust. So for this, there is 5 set of principles that has been present right from the time the group's inception. First, it's about integrity. So any operation, anything that is being done, it comes under public scrutiny because we are part of the society. The society should be able to evaluate whether whatever we are doing is right or wrong, whether it is correct, whether it is in the long term bringing in a difference to the community. And there's a lot of caring, show respect, compassion, humanity, and always work for the benefits of the communities we serve. See, India is a big country with a lot of diverse characteristics and culture. What Tata Group always try to do is it says, how do I save a culture? What should I do? Can I save a particular tradition that has been there for centuries? How do I save it? All the causes that we have, that we work on, tries to put that into the perspective. Say that's what is the way we should proceed further. Excellence is always about achieving highest possible standards. There may be a lot of constraints, but we try to do as much as possible. For example, when we launched the nano car, which is the cheapest car in the world, it was $2,500, it still had a bag to protect us. So it was the cheapest car, but we did a lot of innovation to ensure that the car doesn't harm the drivers. Okay. So we always try to achieve highest possible standards here and work cohesively. There's always a statement that more than the outsider, even though there's an external person who can provide the same service to a Tata group at a lesser cost, it's better to stick with the Tata group companies because they have the same value system. And even if there is a contractor whom we take in, what we do is we say all the value systems that we have needs to be adopted by you. You need to follow it. And finally, the responsibility. Try to be responsible, sensitive to countries, communities, environments, so that whatever we earn goes back to the people many times over. The heritage has always been leadership with trust. And trust a Tata person to say that, yeah, he makes a decision that is best for the community, for the country. So now how do we go about doing it? The first thing is the responsibility as a principle has been institutionalized. So anything that we do, we are mindful of so many things. We say, what is the environmental concerns, social concerns, moral responsibilities, consumers, employees, shareholders, etc. I could state a case here. Around 25 years back, when we were in the financial services business, TCS, the Tata Consultancy Services, started a new product on banking. So we had been doing this. We got the Quartz reference model as the basis and started building a solution around it. And then we went to a specific bank in Rajasthan. And what happened is that the bank general manager said, yes, I like your product, but then his superior was into some form of bribery and corruption. So he said, I will take a different product because they are going to give me, there's going to be a kickback there. So the general manager called us up and said, see, this is something that I cannot do. I cannot interfere. It is my superior, but this is the state of affairs, and I'm just passing it to you because you're very honest people. So what Tata Group did is it empowered the person, whoever is the salesperson who is in charge of handling this particular issue. He says, do whatever is possible, and this kind of kickback shouldn't occur in the industry. So what they did is they went to the manager who is in charge of the MD, the managing director. They told them, we'll get to a non-for-profit arrangement with you. We don't get any profit out of this. We are doing this because we feel that this solution is very important for the country. So went ahead, go ahead, and did the deal. So we take that notion of moral responsibility very seriously. We feel that some places where we can interfere, we should be in a position to bring in a change. The code of conduct, it dictates everybody in the Tata Group. We should always assist in improving the quality of life in the communities in which we operate. So we have people who go in every weekend, they go there, they go around, try to say, can we educate a community? Irrespective of what the community is from, we don't expect anything in return. We go ahead and try to say, can we make them better? Can we try to do something different for them? So for this, there are a lot of things that is being done. There's a big collection of information that captures everything that has been done in the last 150 years. But what I will try to do is I will categorize it into 5 different streams of areas and try to put in cases where this was done. The first thing is giving back to the environment, because if we look at Tata Steel, we are taking it from the environment, we're taking it from Earth. So how do we give back to the Earth, in which we are part of that particular world? So how do we give back? The second thing is the people who live the vision. So all the employees, all the people, the associates, all the contractors who live the vision of the Tata Group, how do we give back to them? Without involving them, there's no point of speaking about how do I give back anything to anybody. Then the families. It's not only the people who are part of the Tata Group, it's also their families. Because what we see is, if you become the Tata, then all of us are one big family. Then the countries in which we serve, how do we give back? And then the communities which are impacted by our business. So these are the few causes I have identified. And I will give some illustrations of pictures of what we have done in each of these areas. The first is Tata Nagar. It was set up in 1910. What we did, this was before independence. JRD Tata wanted to set this up. He wanted to take the latest technology that is available in the Western world and bring it to India and said, I want to do it, but I want to do it in a different way. I want to make the city green. It should be clean. It's a steel city, that's right, but I want to bring in a difference. So what we have is the cleanest city in India. Everything is supported by the Tata Group. They have set numerous hospitals, and they tried to bring in this difference here. Next, there are mines. What we did is, this is an area where it was arid. There was not much forestation available, and we went ahead and tried to bring forest here. So this is a total mine area, and what they did is, you can see around the borders, wherever possible, they tried to put in plantations over a period of time. Then, Masir. This is a very important fish. It's the most 20th megafish in the world, and what is happening is that it has been almost in the point of extinction. For the last 40 years, the Tata Group has been breeding this fish and then populating it across all the rivers of India. It's called as a golden Masir. There's one more thing that Tata Group keeps doing. And the Tata community, the Tata commitment is about diversity and equal opportunity. You have the opportunity to do anything that you want. That is beneficial to the group, that is beneficial to the society, and that is beneficial to the industry. And everybody gets an equal opportunity, irrespective of their age, irrespective of the gender, irrespective of anything. I can go ahead and say, I want to bring in a difference in healthcare industry, I can go ahead and do it. Nobody is going to prevent me from doing it. They rather encourage me to do things differently. And also, respect for individuals. In 1868, when the Tata Group was set up, it introduced the notion of insurance for the textile people. Said, you are operating missions, so there should be some form of insurance so that your family can benefit out of it. The 8-hour working day was introduced much before it was introduced anywhere in the world. The provident funds, profit sharing bonus, gratuity, internship, learning and education, sponsorship, everything is part of the Tata journey. So it didn't stop there. Said, okay, now if you are going to improve a country, then we should bring in good education, research. So all these are premier educational institutions set all over the country by the Tata Group. TFR, NAS, social sciences, arts, as well as in science. So all this, what is happening is that over a period of time, they pass it on to the government. They say, okay, you have set it up, done it, take it over. Another thing is, India being a large country, 1.5 billion people, we have more than 70% of the people who are adult illiterates. So there is something called as a national literacy mission who tries to bring in a difference, but it's not found to be effective. So what we did is we said 40 hours literacy. So the computing systems are put together so that we can educate people. Again, significant amount of people who are below the pyramid, who don't have the ability to treat themselves for cancer. So all this is given for free in the Tata Group. There's an hospital, the Cancer Care Hospital, which has facilities. What they do is they go, they say, okay, this is the purpose. Whoever is willing to charge, they can do it. The others, they do it for free. Empowering children. It's a very critical state. What is happening is that in the state of Uttar Pradesh, that's one single example, there are more than 10,000 madrasas where people who are not getting, just going through the religious learnings, but they don't get formal education about anything else. So now what our group felt is, if this is a situation, then it is going to be very bad for the country as a whole. So they said, can we use computers to teach these people? So that's what they have been doing. They have put in computers in more than 1,000 such madrasas. They said, we would like to teach them what is reality and give them an opportunity to learn by themselves. And then beyond resettlement and rehabilitation, we go ahead, try to say, so you see the huts there, that was the earlier state. What the Tata Group did is, this is what is set up in Kalinga Nagar. They set up the entire city, the houses, the huts were converted into permanent dwellings, and all the people who are living there, they were educated. schools were set up, hospitals were set up, colleges were set up, and they were the people who were there, they were educated, they were given some skills so they can do something better. Another issue that we do is, since we are setting up so many organizations and plans all over the country, there is a significant migration population. So what we do is we realize that there is malnutrition because there are too many kids there. So Tata's try to handle the malnutrition by giving in this midday meal schemes. Try to say, okay, if they set up a school and then say we give midday meals for them, go ahead and keep doing this. Poverty reduction, try to give everybody a chance to live to their potential. Find something in which they can be educated and keep educating them. Finally, for the sanitation people, how do we improve the sanitation conditions of the country? We need to empower the people. So they started investing in instruments that can be used by these people. Finally, why do I show through all this? Show through all this because sustainability is not an endeavor. It's what the Tata Group was. It's what we are presently and what we leave for the future. Thank you.
Thank you very much, Anand. Beautiful talk. We'll take questions at the end. So I'd now like to introduce to Rick Duff, who participates in a lot of stuff that we do at INCOSE. He's a member of many working groups, and he's going to talk to you now.
He's going to talk to you about something.
Yeah.
Thank you. I left my glasses in my hotel, so I really can't see many of you at all. Oh, here they are. I didn't leave them in the hotel after all.
Should put your glasses on.
Okay, so how many people in here count themselves as a system engineer? That is less than half. I would contend that the rest of you are also system engineers. You just have a misrepresentation in your mind of what a system engineer is. Okay, enabling and facilitating engineered sustainability. So I'll be talking about artificial systems, though you may not recognize that in some of the things I'll have to say. Let's see, there is a forward here. I guess it's there. Okay, assertions. I should give you some background on so that you can have some faith in what I have to say. I have been the leading researcher in the space about Agile Systems since its inception. We started the movement in 1991 at Lehigh University, funded by the Office of the Secretary of Defense, in an attempt to understand what comes after lean, since the world is reeling from the Japanese concept of lean manufacturing, lean enterprise. We spent 3 months, 5 days a week in workshop with 13 companies from completely different sectors, trying to understand what do you all have in common that will determine the competitive environment in 10 to 15 years. Half that time, a month and a half, was taken with bitching and vetting and moaning, right? Then we got down to business, and what everybody agreed to in the end was that things were changing so fast in all different dimensions relative to enterprise that they just couldn't keep up. And so we pronounced the next competitive foundation as being the Agile enterprise, with no clue as to what that meant. I've spent all my time since 1991 trying to understand what agility means in systems of all kinds, not just enterprise systems. And so I'm going to share with you some of the things we know. I won't be spending much time telling you and proving to you how we know them to be true, because you had to be there or you have to have read a lot of the literature that we've produced. But I will share with you some of the things that we understand enable and facilitate high agility in any system. And I would contend that sustainability and agility are hard to distinguish. Hello, this way. Okay, well, I think I said, okay. So a lot of what we've come to understand is done by honest research. We spent a good part of the 90s examining, analyzing, in structured analysis teams, hundreds of systems of various kinds that claimed to exhibit this ability to move effectively in an unpredictable, squirrely environment, right, where things keep changing in the environment of the system, and the system somehow has to dance effectively with it. We started out with a small hypothesis. We went and examined the systems of various kinds and basically expanded a set of principles, came up with an architecture that was common across all of them. I will share that with you. We are doing a similar project now again through INCOSI, International Council on System Engineers, for those of you who don't know it. What we are trying to do now is understand the behavior aspects. I'm going to show you past research that basically develops structure and architecture. Now we're trying to understand behavior on how you operate an Agile system effectively for sustainability. I used to call this UURVE. Some wag said, well, if you'd find a way to make unpredictability start with a C, it would make more sense as an acronym. So you're the first to see this. I always hate it when you spend a year and a half publishing papers with a word and then you decide it needs to be changed, but here we are. Okay, right now, and what we're trying to do is go out and look at people in 3-day structured analysis workshops who claim to have system engineering processes that deal with a very squirrely environment effectively to produce product. And what we have them do to us day one, first day, is tell us what their curve environment is about that justifies their belief that they should have an Agile approach in system engineering. And so we have them talk to us about what is it in your system engineering environment that's uncertain, risky, variable, evolving, and capricious. That gets us started. We look at the need for a system, and I use the word system very broadly. I mean a process for doing system engineering as well as the product that is produced by a system engineering activity. And I look at agility as a two-dimensional concept, a proactive dimension, a reactive dimension. The reactive dimension is basically being able to respond effectively when somebody throws something at you that upsets your equilibrium. And that's how all the movement in the 90s for Agile Enterprise got started, because the Japanese had thrown the lean curve and everybody's trying to figure out how to catch up. And so the initial work that we did back then was really all about trying to figure out how to react effectively to something that has changed in the market environment and to do it very fast. And so initially we measured, or thought that we were measuring, agility in terms of speed and agility in terms of ability to catch up. We came to understand before the first year was up that there were more metrics than just speed, and we came to understand that there was more than catching up. If you were good at knowing how to catch up, maybe you had a skill set that you could use proactively and let other people catch up. And so we came to understand there was both a reactive and a proactive dimension to this concept of being able to dance with your environment, to take advantage of opportunity, as well as to catch up when things didn't go so well. We've always looked at that lower right-hand corner as resilience. The resilience people, like the Agile people, like the lean people, are into string theory. They want their word to mean everything. I don't look at resilience as having a proactive part to it. I look at that as an innovative concept. I see them both fundamentally enabled and facilitated by a very common architecture. And it's an architecture that I iconically represent as an erector set, a Meccano set for those of you from Europe. It is basically a response construction architecture. And what we see in Agile systems and what we see in Agile processes, in Agile enterprises, are basically a fundamental underlying architecture that lets things be manipulated and reconfigured and augmented and evolved very easily because they are enabled by fundamental infrastructure. Basic components here are a set of resources, which we refer to technically as encapsulated modules, which simply means that they are resources who can accomplish tasks, but how they accomplish the task is not exposed to the outside world, so that, in fact, the methods of how the tasks are accomplished can be changed internally. That doesn't shine through with an erector set because we're being very specific here instead of in the general concept. But you've got a set of resources up the top, and the idea is that you can plug them together in response to a situational activity that requires some specific response. And you can plug them together because you've got an infrastructure down there at the bottom that talks about interconnect. And we basically have come to understand that there are at least 5 elements of interconnect that need to be considered. That doesn't mean they're always present. The erector said, I can't put anything down there for security. But I can definitely put things down there for safety. And this is an iconic diagram, so this is not meant to be exhaustive. It's supposed to give you the concept of what we're talking about. We're talking about a fundamental underlying architecture that enables augmentation, reconfiguration, evolution. Even though you might be building a Ferris wheel and you think that's your architecture for your system, what enables you to deal with that as you work it, develop it, and design it is an underlying architecture about your process. Okay, so also the work in the 90s, and it didn't stop, but the discovery activity was in the 90s, came up with 10 design principles to flesh out the architecture of whatever it is that your system is attempting to produce. Reusable, reconfigurable, scalable. I'm not going to deal with these in any depth of sense. I just want to give you a feel for the level and the scope, and we don't have 137 principles here. We've got something very small that can be applied in a wide variety of directions. What we are doing now is trying to come up with something in a very similar vein for the behavior of the system. I mean, it's one thing to structure and architect and flesh out the design of the underlying system. It's something completely different to actually operate it through time. And so we're asking ourselves in the workshops that we are doing now, where we're analyzing people's processes in a structured method to try and find out, why does this work? Or why does this not work so well, right? We've done 4 of these at 4 different places with 4 completely different processes, producing 4 completely different kind of products, but they very definitely needed an Agile approach. These are 3-day workshops with a lot of prep in advance in terms of what has to be presented and what we have to do to analyze it in a structured way. We did not have what you are looking at here on the screen even in mind when we completed the first 4. This has happened since then. The first 4 got completed in October. One case study is written up and was just delivered in Scotland at the INCOSI Symposium. The 3 others from last year are work in process right now for submission at the next INCOSI Symposium in November for submission. In the meantime, we're attempting to do a second round now, 4 to 5 more. We expect to have somewhere between 10 and 15 before we think we can make a fairly solid statement about fundamental behavior principles that we see everywhere, that we think are necessary, and we hope to say sufficient as well. Of course, they are at a high enough level that we will have examples of how each one of these principles is implemented in a variety of different contexts, so that people will come to understand what the values and benefits and intents of these principles are, instead of having a recipe that says, do it this way. The key one down there, I think, I don't want to say the key one. One of the things that we come to understand very much in all of the 4 that we've looked at, and the more we think about it, we've seen it in all the things we've looked in the past when we weren't doing analysis, is awareness is highly important. And when I say awareness is highly important, I mean there has to be something very specifically instantiated whose function and job and process and intent is to be aware of the external environment and the internal environment all the time and work intimately with the people who are managing the rest of the... It is an intimate part of the Agile process, whatever it is. Without a constant, dedicated activity to be aware, be alert, evaluate, does what we just saw happen affect us? Is it important? Should we do something about it? I don't care how agile your capability might be, you don't know when to employ it, right? Okay, the mitigating thing is not worth talking about, I think, at this point, but evolving is very key. I expect some of you are aware of what is called Agile in the software development environment. You know, they use it as a noun. They say, oh yeah, we do Agile. What they're referring to is a family of software processes and approaches that have collected under that noun, which really doesn't help you with the adjective meaning of being agile. Well, we have come to understand in analyzing what goes on in that family of software development processes, as well as everything else we have looked at in a variety of different domains, is that the fundamental concept is really learning loops. You know, what you're trying to do is learn what you should have been doing 5 minutes ago, what you should be doing in the next 10 minutes, by constantly observing, reevaluating, mitigating, and going forward in a dance with the environment that your system is working in. So evolution is very important, and also something that has to be managed very explicitly in an effective Agile process. Because we're in the system engineering world, we can't go off and do our own thing that is not cognizant of, and perhaps, I want to say, complementary to, the 15288 standard for software and systems engineering practices. And in fact, we are trying to build a life cycle model in the sense of that standard so that we can communicate with the people who believe that standard rules the world. 5 minutes you want to give me? 10 minutes, okay. You know, the expectation in that world, the tradition in that world is a waterfall process. You do some concept development first, then you do some development, then you do some production, then you do some utilization, and then you kill a system. It doesn't work in the environment of an Agile system or an Agile system engineering process. And of course, you don't need an Agile system engineering process or an Agile system unless you want something that's going to live forever. However you want to define forever past the ROI point, at least. Okay. What we've come to see in everything that we looked at is, unlike 15288 tends to lead you to, these things, these various stages and these various tasks are not discrete events that happen in any sequence. They happen all the time. Well, not really all the time. They happen any time that it is appropriate for them to happen. There is no requirement that you must have done this before you do that. There is no requirement that you can't do this until after you've done that. Any of these things can happen at any time, and they do in all the places we've looked. Oh, and the new one we've added there, of course, is, we call it research, but what we really mean is being alert and aware of what's going on now, what goes on in the past that affects what you're doing now, and it's both internal and external alertness and awareness. Evolution is very important in everything I'm talking about, and many of us know evolution in the Darwinian sense, where you've got variations on a theme that go forward. There is also horizontal evolution, which is known to be the primary source of innovation. Things get borrowed from someplace completely different and adapted for someplace here. This happens in our bodies. You have borrowed genes all of your life from other life forms, plants, animals. Thank goodness they don't get expressed, right? But they are there, and when they do get expressed, appears to be under times of great stress, where the organism swings into a high experimentation mode. But the concept of horizontal gene transfer, which I like to call now horizontal meme transfer, is very much important in the innovation of systems activity. At Home in the Universe was a book written by Stuart Kauffman. I used to make my students read it. They never understood why. This is my advanced Agile course. I take a very liberal definition of life. To me, life is anything that evolves. You know, it doesn't have to be squishy and organismic. What'd you do, just say 5 minutes? The universe evolves. And I want to make this distinction because there are two types of evolution going on here, and I'm not talking about horizontal versus vertical. In organismic life, you know, the requirement for a memory is satisfied by the genetic code, DNA, and it's guided by natural selection. What we see in non-organismic evolution is more like a trajectory through stages. And the stages you can get to can't be leapt to from other places. They tend to be with options, some series of things. And I make that distinction because we are now getting interested in looking at some complex system of systems and their evolutionary paths and their need to be agile. And we're noticing that there are quite a few out there that tend to be on an evolutionary trajectory. I like to say to the right when I'm talking about the U.S. democracy, and to the right when I'm talking about Wikipedia and its. I mean, Wikipedia is not the democracy it was when it came. It had a very good, clear sense of culture and values and what it was trying to do. And over time, it has developed a power structure. U.S., and I won't speak for those of you who aren't in the U.S., but in the U.S. it's been very clear that we've got a power structure that now takes whatever we used to call a democracy, even though some people would like to call it a republic, and make it, and put it, it's an oligarchy, okay. How old is the oldest enterprise? You know. How about the Catholic Church? 2,000 years? I don't know. Something like that. I'm sure there are some others that would be in the religious vein. Why do they last so long? How is that possible? And I'm going to suggest it has to do with a core of culture and values. Instead of a superficial, we need to make some money, we need to grow the church, we need to do these superficial things that come because of a very core set of concepts. And I'm suggesting that enterprises that have a very good core set of values can do things that throw off, as a side effect, the benefits that shareholders look for. Okay. Security, we're now working in the space of agile security, and I'm not going to have very much time to talk about this at all. In fact, I don't want to talk about it because I want to talk about something else instead shortly. That's a wrap-up of what we've done here. But we're looking at what I'll call Security 2.0 as being agile, necessarily so because the bad guys are highly agile and the good guys are just getting drugged down the street behind them, trying to catch up. Some of the things we're looking at, a component conscience. I'm looking at everything in a network has to have a conscience, a little agent on the side that watches what it's doing and says, am I behaving the way I should be behaving? Also, we need peer behavior judgment, where a bunch of the nodes are watching each other, saying, is anybody infracting the rules here, going wacko? Do we need to make a rogue elephant out of this elephant, banish it from the crowd? Things to think about. Sustainability is a natural selection fundamental. I want to say you really can't do anything about it. It will happen without you. It is what happens. What you can do is slow it down, speed it up, and screw it up. And that's not to say you should ignore it. That's to say understand that's all you can do is slow it down, speed it up, or screw it up. Try not to screw it up. Epilogue, okay. Now I want 5 minutes. System engineers, we got it cracked. The system's in the bag. It's all designed, it's all delivered, but we don't own it. The environment owns the system. And if the system isn't ready to dance with the environment, it doesn't matter what was built. Every day is lived with uncertainty. It is the way things are, and we know how that works because here we are, walking and talking and chewing gum still. But there is this other crazy idea. I make things better. I'm an engineer, right? But when I look at the kinds of things we're dealing with today, you know, they keep building on the things we've done yesterday, built upon the things we've done yesterday, and now we're very aware of the complexity of the kinds of systems we're dealing with, and it's just a natural evolutionary trajectory of the kinds of things that technology develops. And it's collapsing in a variety of places because we built things that are so complex we don't understand how to deal with them. But what we do is we throw some more things into that system environment and make it more complex. I'm claiming that we need a very different view on how that is. We can live with this thing that we call complexity by living with it instead of trying to control it, right? So what I'm suggesting is that we have a confrontation right now in system engineering circles on should we control it or should we understand it and maybe roll with it? Although I don't think I've really heard people say roll with it yet. So here's Systems Engineers 2020. They're trying to control it. Here's the future of system engineering. We're shepherds. We're trying to roll with it. We're trying to ride it. And my suggestion about all of this from what we're looking at in terms of discovering what makes agile systems, which are synonymous with sustainable systems, is an ability to integrate with the laws of nature. You know, and I'm taking a loose definition of the laws of nature here. One I'll put down at the bottom is natural selection. We can't fight that. It happens. We can slow it down, we can speed it up, and I'm done, he says. Okay. Well, are you an innie or an outie? Okay. So we're in the age of complexity now. I think we're going to come a rude awakening very shortly because we can't deal with the complexity that we are causing and we are building. Finito.
That was great. So thanks, Rick. That was really great. So we've heard of things from a global perspective. We've heard of things from a process perspective, and now we're going to be thinking local. So Diana is going to be talking about the Gwen Project. Thanks very much. No?
Okay, how about now?
Yeah.
Yay. Okay, so my name's Diana Mann. I'm a systems engineer with Ball Aerospace, but I have this intense passion for dealing with global phenomenology. Okay, is that better? Perfect, thanks. You want me to start over? Okay, perfect. So what I'm going to be talking to you guys today about is the Global Water Energy Nexus, also known as GWEN. Just because we have to give everything acronyms in the aerospace community, this ended up as a name. So this is going to be really thanks in part to the Colorado Front Range chapter of INCOSE. I too am a member of the International Council on Systems Engineering, and in our Colorado Front Range chapter, we've been working the last couple of years on trying to develop ways to deal with this water energy nexus in the context of engineering sustainable systems. So with that, I'll go ahead and get started. So what is GWEN? It's really a set of supremely complex socio-technical interdependencies between three fundamental resources: water resources such as precipitation, reservoirs, groundwater, this kind of thing, and all of the energy that's required to distribute and treat those resources. The second big category is the energy resources: coal, natural gas, renewables, nuclear, everything that creates power that allows us to create distribution systems for water and to make sure that it's purified for human and other use. Now, the third big component in this is consumers. And as we all know, consumers are voracious. Doesn't matter what they're consuming, they're going to consume all of it in a space before they move on to something else. Now, this is not limited to just human interaction with the environment. Animals do this too. We see this in every possible biological system on this planet. So this now then is trying to figure out how to deal with this triumvirate of resources that are competing for its use. Now, because of all of these intimate complexities, this means that Gwen is fundamentally a wicked problem. Now, wicked problems are very interesting things. According to Wikipedia, they are really difficult or impossible to solve because there's often contradictory, incomplete, or changing requirements that are really, really difficult to identify and codify. So with the diagram on the right, my other right, largely what causes some of these conflicts in the requirements is that our stakeholders who are intimately involved in the use of these resources can't necessarily agree on the right way to utilize them. We also have a set of complex requirements that really require an intimate knowledge of how these systems work. So it requires complex judgment on the part of the people who are using these resources to figure out, well, how can I best use them? How can I make them the most sustainable for the most people, given what I have available in this system? Now, some of the other things I'm not going to go through, but by and large, this is an iterative process to go through to try and figure out what are the boundaries of this wicked problem. And at this point, traditional systems engineering disciplines tend to start to fall apart. As the previous speaker just mentioned, we have these really significantly complex systems that are evolving over time. And so systems engineering can either be crushed by that evolution or it can evolve to meet it. But oftentimes, the solution to these wicked problems requires some level of transformational thinking so that we can transcend the current limitations imposed by the problems. Okay, so one approach to addressing something as complex as Gwen is called transformational systems engineering. There is a little division within INCOSE that is doing this. They're largely out in California. But what they propose is to have two fundamental core principles for addressing these complex problems. The first one is to use data-driven analysis to identify stakeholders, identify their paradigms, figure out what some of the emergent behaviors are, and then to, on the other pillar, synthesize all of that information to provide really rock-solid data-driven recommendations. So it allows us to find the sweet spot in the center of this triumvirate of very dynamic resources and consumers. So it allows us to build a framework in order to evaluate the potential socio and technical solutions that we as engineers need to come up with to address some of these problems. Okay, so let's dig a little bit deeper on what is transformational systems engineering. It is a set of systems engineering practices that literally emphasizes analysis of a system and of designing, I'm sorry, forgive me, let me start over. It's analysis of, and the synthesis of design and engineering methodologies. Well, you try to practice that and it still comes out messed up. But at any rate, the graphic on the right kind of shows that depending on one's perspective, things can radically change. So identifying things like existing paradigms among all the stakeholders, and then applying some data-driven analysis to those paradigms to understand the limits of what those models of the world look like and how we can transcend them to get better solutions. The synthesis end of things involves a very complicated new thing called system of systems thinking, which lets us create paradigm shifts and fundamentally manage the emergent behavior that comes out of this complicated interdependency. So bottom line, transformational systems engineering systematically allows us to assess the socio-technological possibilities that we can come up with to address things as complicated as Gwen. All right, so let's go ahead and do a case study. What does it look like when we apply analysis to Gwen in terms of identifying stakeholders and paradigms? So what we have on the screen is a list of stakeholders that the Colorado Front Range Group has been working to identify over the last 2 years in regards to Gwen. So we have water producers and consumers. That's pretty much things like agriculture, industry, rural and municipal consumers, energy producers and consumers. So anywhere you see a mine, they are producing energy for us in some way, shape, or form. Anytime you see one of those lovely little oil derricks that's kind of just pumping away in the middle of Kansas, that's producing energy for us. We also have a group of regulators and advocacy groups that really are influencing the political decisions and the regulatory landscape for how we utilize and manage our water and energy resources. We also have things like critical infrastructure. For instance, in an emergency, do you really want a hospital to not have power? No, that doesn't make any sense at all for making a sustainable community. But we have to deal with things like emergency medical services and fire departments that also need to utilize these resources. We need to very much be aware of what the end users are doing with the water. Agriculture has a bad rap. Everybody thinks, oh, those darn farmers, they're sucking all the water out of the Platte River, which is our major river here in Colorado, and they're watering the grass. What are they doing? Well, guess what? They're feeding us. They're using this to either give us our vegetables and whatnot, or they're raising animals to feed us that way. So we can't just give them a black eye because of this. We also can't just slam all the municipal users because they are trying to figure out how to use these resources effectively. Because it costs us money. Every time we turn on a light bulb, it costs us money. Every time you turn on a water tap, it costs you money. And so everybody who's a consumer of that says, well, wait a minute, I don't want to pay $17 million every time I turn on the faucet. That's no good. That's not going to work. So there's a level of sustainability that we can even start to input into the socio part of things. But lastly, and I think probably one of the more important ones in terms of stakeholders, is the actual environment. From the perspective of getting clean water to drink, we do not want to drain marshlands. That wrecks all kinds of other environments that we have not yet figured out how to deal with in terms of resource management. So all that effort just to list the stakeholders took us almost 6 months to figure out, okay, who are the people that are impacted if we start trying to address this problem? Now, from that list of stakeholders, this is obviously a little bit of a simplification. We start looking at the paradigms those stakeholders operate under. And really what that is just the models of how they think. And it's the job of the systems engineering group, and what we're doing here is to identify the limits of those models. That way, we can understand their paradigms and create opportunities to transcend them, to do something better that's in everybody's best interest that still focuses on sustainability. All right, so now let's continue our case study with applying a little bit of data-driven analysis. The first step in a 5-step decision-making process that we're starting to look at as the way to deal with all of this data that we're uncovering is shown on the right. It starts with understanding the stakeholder paradigms. So the previous step where we identified who they were and what they are using as their paradigms allows us to start this process. It's sort of the entry level into this very iterative thing that we're doing that says we now want to create analysis plans with some really solid hypotheses and collect relevant data to see whether those hypotheses are correct. Now, basically, this is the scientific method, and everybody that's a systems engineer fundamentally loves the scientific method. We say, oh, yay, we get to collect some data, run some experiments on it. This is great. But to collect the relevant data is a little bit tricky. In the Gwen context, that relevant data is inclusive of things like census data. So the more accurately we can count the number of entities using the resources, the better off we are at saying, okay, here's how many resources we need. We have water use data, electrical use data, power use data, that we're all starting to look at these gigantic big data sets and figure out how to utilize this to understand what's going on in this complex system. As we gather insights from all of those data and analytical methods, it allows us as systems engineers, as responsible stewards of our environment, to make sustainable recommendations on all of these socio-technical solutions that we're generating. All right, now we're going to take a look at this other pillar, applying synthesis. And I'm going to take one step back and talk about how systems are in fact combinations of interacting elements organized to achieve a single stated purpose, or sometimes multiple ones. But something interesting happens when you put one system in a group of other systems. Previous speaker mentioned that this gets extraordinarily complex very quickly. And there's an example on the right here of the Global Earth Observation System of Systems. It's literally an integrated system that allows us, excuse me, to do disaster monitoring, health data collection and information management, energy data and information management, climate, agriculture, and you guys can read the rest. But it is an extraordinarily complex, big systems composed of a bunch of little constituents. And these systems of systems are characterized by both operational and managerial interdependence of each one of these little guys that makes up the big systems. They're often geographically distributed, and they really display this crazy thing called emergent behavior, because their interactions are so complex, they're distributed, there's no one brain trust that manages the entire thing. Little new behaviors start to pop up. It's like weeds, but it's a little bit more exciting than that, because within those emergent behaviors are opportunities to do better technology. So that also leads us into some evolutionary development. But really, this system of systems thinking is all about a problem-solving method that lets us address emergent behavior at that big system of systems level. So, emergent behavior. One of my good friends helped me build this slide because I just asked her, I said, how on earth do I show this? Because I want to show how one technology over time changed. She said, okay, that's great. What's the context you want to show that evolution in? And I said, well, I kind of want to do a comparison on energy use. And so she said, you know what? Light bulbs. And I was like, all right, light bulbs it is. So here we have three realms of emergent behavior. We have social stuff that happens, which, people move in and out of an area. Their beliefs and their values change over time on how to use resources. Our technological realm, it kind of focuses on new energy production and utilization technologies. How do we manage that? How do we develop policy that addresses it and encourages it? In the water sort of world, we have reclamation and distribution technologies that really contain the seeds for making it all much more efficient and more effective in terms of how it interacts with the energy. And we also have our environmental realm, where we have resource availability as well as the need to develop sustainable mitigation strategies on how to keep these resources sustaining over time. But now to my light bulb example. I love this. In 1879, we had the development of the incandescent light bulb. That by itself is a remarkable, remarkable achievement, because here up to that date, everybody was using candles and oil. Great. So we finally get one really brilliant insight, and that's why we use the light bulb as a means of describing insight. It puts out like 100 watts worth of just energy. It consumes this, it puts out excess energy as heat, and you're just kind of going, incandescent bulb. Well, it took us 116 years to figure out, oh wait, that's maybe a little bit inefficient. So there was this seed of sustainability that sort of grew into this new paradigm. And we made a factor of 5 improvement in the amount of energy that these little light bulbs consume. Now, each one of us has had these silly little compact fluorescent light bulbs in our homes. They bust after about 6 months, and we're like, oh, don't, this is not the right solution. So it took us another 15 years to figure out a light emitting diode, which everybody's like, yay, this will last 100 years, this is perfect. And it gives us a surprisingly little amount of energy consumption, 20 watts. So this is an engineering evolution in a design that was really sparked by a paradigm shift towards sustainability. And yay, hats off to my friend who helped me put that little slide together. So next, this is kind of my last slide, but this one bears the most, I think, weight. So, in summary, we have a couple of keys to transcend the current socio-technical limitations, at least within the Gwen paradigm. And those keys are the two pillars that we've been discussing: analysis, synthesis. We can use these core principles and apply them to these types of complex problems that have severely complex interdependencies between all the little groups, and we can manage this successfully. It's going to take a lot of work and a lot of ideas and a lot of people from different points of view to help us come up with this solution, but it can be done. The second key is to cultivate collaboration among the stakeholders. Because when you have a whole bunch of stakeholders that have really different opinions on how things need to work, it's very, very difficult to harmonize that. But that's the real power of what systems engineering can do. We can address this by bringing a disciplined, systematic approach to the utilization of our resources. And the bottom line here is that we can improve efficiency at every single level in this resource utilization problem called Gwen. So fundamentally, transformational systems engineering techniques really do enable a portfolio of potential solutions to really complex socio-technical problems such as Gwen. And it really lets us find that sweet spot in the middle that lets everybody get pretty much what they need. And that's it.
Keep it on for now. That was great. Thanks very much. So again, that was a really nice example about how diverse stakeholder perspective can be brought together to produce a beautiful solution. Yeah. So can I ask the speakers to come and join me over here? Let's go and stand in the middle. So we've got plenty of time for questions. So Gerard?
Thank you very much. Very appreciate the light bulb is a good example, but there are some problems. Well, thank you, but I have some problem with the light bulb. What's the footprint of the new LID? I don't know it really. And now it's not only the footprint, it's the second. You have to carry it to a special recycling cycle. The old one, it was just a little bit of wire and glass. I just threw it away and it was fine. So how we are comparing that?
Right now, sorry. Thank you, sir.
It's okay, just hold it.
Okay. So right now, the way that we're comparing it is simply the energy consumption on each one of those little light bulbs. And I understand exactly what you're talking about the footprint of the slightly larger way that this technology gets addressed. The gentleman was absolutely correct. Our previous way of dealing with a burnt-out light bulb was to toss it in the recycle bin because it's glass, and glass is infinitely recyclable. The CFLs, compact fluorescent light bulbs, they're much harder to deal with. They have mercury in them, they have all kinds of other junk, and so we have to take them to special recycling places. So the level of complexity of that evolution was unanticipated. That in itself is an emergent behavior, that part of what Gwen is trying to accomplish is to identify even that, to say how can we plug the technologies as they evolve into an existing infrastructure that's not ready to deal with things that complicated. Correct. So thank you for your question. Yes, ma'am.
No, hang on.
I have a question for Rick. I'm a system engineer working in project management, and I'm doing some research into human factors and project management. And generally, human factors deal with safety and design, but we are looking at behavioral aspects of human project management, like leadership, motivation, teams. So the work you're doing in agility in terms of behavioral aspects, does it have some correlation in human factors in engineering as well?
The first case study we did was of a group in San Diego, a Navy group in San Diego, a 3-day workshop that blew us all away with this guy who stood up and talked about the process he had invented for making order out of a very chaotic system engineering environment. And when we analyzed during those 3 days, what didn't come out came out later on when we tried to make sense of everything, and it was all about his soft skills and the support he put underneath for his soft skills. And we basically focused in this paper on what I called consciousness, culture, and conscience. And it was the human factors. I mean, what he did was weld together a group of 60 engineers, half of whom were outside subcontractors, and got them all to buy into a common culture. He provided a data infrastructure on what was going on a daily basis by everybody that was so effective. We likened it to a symphony orchestra where you got 100 musicians, and if one of them makes an off note or an off timing, everybody knows it instantly. They did that. It was very effective. And from the culture point of view, it was a culture of engagement. If you were one of these 60 people involved, you were expected to be engaged. You were, I don't want to say you were monitored like there was a policeman walking around, but it was immediately noticeable to everybody the instant your engagement fell off. And there was therapy to get you either back engaged or get someone else to be engaged. Right? So, I mean, their success, we went through the process they used in very process-oriented ways and very interesting aspects, but their success was all human factors.
Thank you.
Dennis? Microphone, please.
There were 3 things I didn't really hear, maybe I wasn't listening properly, from all 3 speakers. The first was entry. How do you first start out? I didn't hear that. The second one was exit. How do you finally get out of the thing after you've finished? And finally, conflict resolution. I didn't hear how you deal with that in any of the 3 presentations. And I think at the moment that's quite an important one.
So I'll have a go at that. So entry starts with recognition of the opportunity. That could be a problem, or it could be, a need. So, okay.
Well, in the world I work in, I look at Agile systems as continuous systems. We do have some concern about how does somebody get from an in-Agile approach to things into an Agile approach to things. We frankly have not spent any time asking how to do that. Instead, we've gone and analyzed people who've been on the other side of the fence already. Exit, I don't recognize as something of big import in the space I deal in. I'm looking at life-sustaining systems that go on forever. Now, I know nothing goes on forever. What was your other one? Entry, exit, and conflict resolution. We come back to the soft skills area, and conflict resolution, we don't talk about it that way, but we talk about it in terms of what I'll say is a negative cast in terms of conflict resolution, and a more positive cast about a common collective culture, that's also a collective culture of not just engagement, but of mutual self-help. And one of the big things we've seen when we have a variety of engineers from different departments and a variety of subcontractors, all of whom have contracts and have a tendency to optimize their benefit from their contract instead of the benefit to the whole. What we're seeing that really works in all the places we've looked at so far is those barriers are being broken down. Even with strict contracts that originate at the DoD and then get parceled out to subcontractors, we're seeing a requirement by these groups that are effective at it that they expect you to work on my behalf instead of your behalf if it's better for for global behalf.
Do you have anything to add?
For the Tata Group, the entry depends upon what is the community benefiting from that particular endeavor. So when Tata Consultancy Services was started in 1968, it is about improving the intellectual capabilities of a group of people by taking outsourcing, using outsourcing as a means. So that is predominantly the entry criteria. We try to be there for a very long term. The exit criteria is, if I quote the words of Ratan Tata, he says, I do not wish to exit out of anything. I would like to sustain as much as possible. I don't want to lay off anybody. It's not their fault that I didn't do the business properly. So that is how they operate. And conflict resolution, it's always about the people. It's always about the community. What is important for the community is what is important for the group, nothing else. So that is how they operate.
In the context of the global water energy nexus, the entry point is really noticing and being aware of the fact that resources are limited. To say that if you have 100,000 more people come into an area, any area on the planet, if that physical space doesn't have the resources to sustain them, that doesn't work. It literally cannot survive as a system. So the first entry is awareness. The exit is really the point at which the system is self-sustaining in this new paradigm. To say that, okay, our paradigm is a lot more focused on efficiencies. It's a lot more focused on optimization of how to use our resources. So exiting isn't really something that we have tried to specify yet, but it is predicated on, is the system now sustainable in the new paradigm? In terms of conflict resolution, I have to agree with all of my colleagues that it really comes down to the connection between the people involved. If you are not connected with one of the other stakeholders, you have to drop everything and try to get connected with them to understand where they're coming from, what their hot buttons are, and how you can address them successfully together.
Yeah, great, thanks.
I asked myself, why don't we use our wisdom, knowledge, systemic thinkers to create systems not to produce more baggage? You say baggage? Trash, whatever. We are only working on more complex systems to recycle and do whatever more complex. And it's as simple as not to produce more baggage.
That's an excellent point that you make, and I believe that the answer fundamentally comes into the systems as they exist today. These were formulated earlier in time. I don't want to call it out that the 1950s were the problem, but some of the companies that we have today were instantiated in the 50s, and that was not on their minds at the time. That just simply wasn't the paradigm. As time passed, that changed. And to retrofit an existing business to accomplish less waste is something that each one of these businesses is already looking at, because the waste costs them money. It simply costs them time, and time is money. So I understand the question that you're asking. We just have to get in the heads of those stakeholders and invite them into the new paradigm to say, well, how much more can we reduce that? How much more can we take out of this that is wasteful, and thus produce less waste?
These complex systems we are generating is our fault. It's our lack of love. It's our lack of sense, of coherence. So, sorry, but sometimes it's so simple for me to think that we only have to think in simple things, and as you do at home, now you see everywhere you have trash or buckets or whatever to. At home, you have in every place trash, or it's simple. You go to Japan, and you see all the streets are clean, but they have another consciousness. They have to live a war and suffer a lot to realize that they have to be compassion, and they have to be brothers, and they have to work together. So, nothing.
Yeah.
Sorry.
I think you're right, but the world is waking up to that. Yeah.
Yeah,
we have to accept what happened in the past and just deal with it.
But we're also dealing with a very complex system. And let me move you out of your space into another one so that we can see the analogy. When we talk about the healthcare environment in the U.S., and we try and say, how can we lower the cost of healthcare? And if you're serious about that, you start to look at what are the various groups and independent agents in the healthcare environment, all of whom are incentivized with different connections to other things. And you ask yourself, well, why don't we just legislate something different? It doesn't work. And so here, when you say, why are people throwing trash on the side of the street? They're doing it because they don't have a goal not to do it, and they do have a goal to do it. It's an expression of their, well, I don't want to psychoanalyze the community.
We have a question there, and then another one at the back.
Yeah, again, to Diana, perhaps. I'm very interested in the process of how you go about identifying these multiple stakeholder paradigms. Is it a dialogical process? What does that really look like in practice in terms of, when I think about dialogue across paradigms, I'm thinking of kind of a collective learning process, and you refer to identifying so as to transcend, and how is that captured in the actual practice?
Oh, excellent question, thank you. So what we have done in the past with the Gwen sort of working group that we have instantiated in Colorado is we've had 2 seminars so far that brought together systems engineers and some of the leading decision makers and whatnot within at least the Denver water system to come in and talk to us about the Gwen phenomenon, just to get on board with the fact that, hey, there is a phenomenon that is occurring. We also had one of the chief technologists from NREL sit in with us on both of those seminars as well, and it was a very dialogical way of dealing with it. So we started talking about things, we started asking questions of this group of big thinkers to say, all right, what are some of the big hot buttons in your universe? For instance, the Denver water gentleman who was there, he said, oh, our #1 thing is water rights. And all of us were like, what? What's that? And literally, we live in a state that lives under things called water rights. It's illegal for us to collect rainwater. So we're like, oh, that's what that's about. So we started to document a lot of this. We started capturing it in PowerPoint, in OneNote, in these sort of electronic methods. But then our next step is to go back through and say, all right, now that we've identified who the stakeholders are, let's identify maybe some of their paradigms, and we start to say, all right, we think this is it, but now we have to go out and talk to them. We literally have it upon ourselves as the next step to go start a dialogue with the actual stakeholders that we've identified. I mean, obviously you can't have a dialogue with a deer that's eating something in your yard to say, oh, how much water do you consume? But there is data sets that actually capture that. So we're going to try and go out to some of the other big data providers and see if that data even exists so we can apply the analytical methods to it.
Right, at the top. Is that Jim? The chap in the yellow shirt.
I'm a long-time systems engineer. And what you always start out with is a set of requirements. And it's a matter of how you define those requirements. A systems engineer can't do anything without systems requirements. I worked on air-to-air missiles when there weren't any. There was a requirement to defeat an enemy in a particular way. I worked on something called Earth Resources Technology Satellite. You had to have people around the world or some people, determine a set of requirements. The requirements was to map the world for the first time. We did that. So you spend a lot of time on talking about the requirements mode. I haven't heard that term requirement used by any of you. So to be an engineer, you have to have requirements to deal with. And in my experience, that you spend a lot of time, I help establish some requirements, and that's a messy sort of a thing. You do the stakeholders, but you have some pressing requirements, you rank them, and then you come up with a set of requirements that a systems engineer can go ahead and design. And I was wondering why I haven't heard the words on requirements, establishing requirements. So maybe you could address that.
I'll have a go if you like. But
did you want? You don't get the answer.
For the Tata Group, requirements started in 1868 when they asked the question, what will this country do when we get independence? That defines the requirement. There's so many things that needs to be put in place for the country to become better. So that started the initial set of requirements. Then for every business that has been started, there's always a set of community requirements saying what is it that we are trying to do here, how is it that we are going to benefit the community. That dictates what the business is all about. So the requirements, it's always about what is the value that the group itself can create for the country as a whole. So it always starts there.
In the material that I presented, I started out by talking about CURVE. And those are the high-level requirements for justifying the need to have an agile, sustainable approach to a system engineering process, for instance, or for the development of a system. And in the agile space that I work in, not in the software agile development activity, we look at requirements first at the CURVE area. Then we have a second level breakdown in proactive and reactive categories where we identify the kinds of responses that a system has to deal with in 8 different categories. And those form the requirements for the design of your agile response capability. They don't deal with the requirements for why do you even have one and what are you trying to produce. So the word requirements can be satisfied in many different ways. A purpose is requirements. In agile software development, they use user stories. They don't talk requirements. In other areas of agile software development, they use test-driven development. They don't call it requirements, but that's definitely sitting there as a requirements. So there are lots of ways to deal with requirements without using that word.
No. I'll get to you next, promise.
So for Rick, I wonder, it's a paradoxical question having to do with, since you're very good at suggesting how systems can become more agile, how about this, if you have any insights about how to undo with agility dysfunctional systems? Systems that need to be going away. I'm thinking, for example, as I spoke yesterday, of the curriculum in economic departments that is, to my mind, entirely dysfunctional or very close to it, let's say.
Well, I have 2 ways to avoid your question. One, a lot of the things we're analyzing right now that we believe are effective agile system engineering processes came into being because there used to be a different kind of a process that wasn't effective.
Yes.
And people were looking at the funds they were putting in that other direction, and basically the funders were saying, we're going to kill this thing unless we figure out a way to make it more effective. And so there was the threat of death that brings very innovative accomplishment. In the other space, we talk about complex systems here. Let's talk about the healthcare system as a complex system. Many different agents with different kind of incentivized relationships, none of which have a boss, none of which have a system director, right? It's all independent concepts. How do you intervene in a system like that? And I'm just using healthcare because it can be representative of any of the things that we're interested in here. How do you intervene effectively? And I suggest look to biology. We have bacteria that have, I'll be careful, I'll say figured out how to invade a cell and repurpose the relationships in that cell for its purposes. Doesn't kill the cell, but it changes the incentive relationships amongst the small constituents. And I suggest that the way to intervene in complex systems where there is no single point you can go to and say, this is silly, let's change it, is to do a systems dynamics analysis, J. Forrester style, which I don't happen to believe anybody except him can do, but that's a different story. Do a systems dynamic analysis, understand the relationships, understand where the weak points are, and how you can repurpose the incentives in there in just a few places, and it should ripple throughout. Did I avoid that successfully?
No, I thought the second one in particular was very useful to me. The other, with Anand, if I can ask this, have you thought of taking your organization, your model, your institution, the values that are involved in it, and derive from it a bachelor's degree in business that would replicate or at any rate provide a model that can be used in universities to do the similar things that you have done?
We already have it, what is called as the Tata Administrative Service, where we teach people what does it mean to do business the Tata way. So we already have it in India.
Do you have a curriculum? In other words,
yeah,
all right.
We have a full curriculum, we have a full course. It's a 3-year program. What is happening is that Tata Group is very close nexus with the colleges and universities in India. So once they identify there is a very bright person who aligns with the Tata's vision, he is taken into this program. Or either if he is working in any of the companies, he is taken into this program. And for 3 years, he's been educated with the Tata way, and then he is asked to lead one of the organizations.
Thank you.
Lady here.
Elena Leonard, Toronto. I'd like to ask a question about the behavioral aspect of the Agile approach. Do you have a mechanism, or have you been looking at the idea of organizational proprioception, where you might have the equivalent of seasickness in an organization, where there's a disturbance that's perceived at the subconscious level but not necessarily at the conscious level? Now, with a human being, we kind of know what seasickness is, and we have some ways of combating it. But what about when that happens at the organization?
Well, I don't know if what I'm going to say really answers your question directly. I'm very concerned about multi-agent systems and how you detect when something is amiss. And specifically in drone swarms, for instance, where they're going out on a mission and they can't phone home to get direction from somebody calling themselves God in a room somewhere, and they have to make decisions themselves. my proposals have always been you need two things. You need a conscience in each one of those elements, whether it's a drone or it's a department or it's a person in a team. They have to have a conscience that is associated with the expected their own personal expected behavior. And it has to be an independent agent. It can't be part of the system. And they also have to have peer-peer behavior monitoring constantly. We all do this every day. We go to a restaurant and we're minding our own business, eating our food. We're not sitting there looking for aberrant behavior. But somebody goes berserk in a restaurant and we all know it right away. And we make decisions amongst us who know it. Should I intervene? Should I not? Peer-peer behavior monitoring is, it's in your body. Your cells, all the cells in your liver and in any other organ are in constant contact with all the adjacent cells, evaluating the health of those cells and marking them if they aren't exhibiting healthy behavior and something comes in, kills them and replaces them with a new cell. Constant regeneration going on in the body. I don't know. Was that too indirect?
No, that was great. So we're going to have to call it there, I'm afraid, because the coffee's about to arrive. I'd really like to thank my speakers for a really great set of talk. And thank you all for engaging with us.
And I would especially like to thank this panel and Gary for the most well-organized session we've had.